Good morning, students. Today we are going to discuss about modern periodic table. Last class we start the classification of periodic table and we studied several classification. Shall we see what are they? That is first one, Dobrinus. That is, this classification is called as what? Triads. That is, he could able to do how many triads? 3 triads, isn't it? 3 groups, each group with 3 elements of same physical and chemical properties, hence the name what? Triads. But he couldn't able to do the same for the upcoming elements. The next one is Newland law of octaves. Octaves means what? 8. His group contain 8 elements. In that first one and 8th element has same property. After the discovery of the noble gas, he couldn't able to follow that. Okay, so it also came to failure, followed by the next scientist Mendeleev in 1869. He classified the elements, okay, according to the atomic mass. Okay, according to the atomic mass, he arranged all the elements into groups and periods. But his classification also contained lot of demerits. Okay, so these limitations were overcome by the next scientist, that is Henry Moseley. The present periodic table that we are following is modern periodic table. So we are going to learn about what? Modern periodic table. This is the table what we are following now, and it was designed by Henry Moseley in the year 1913, and this table totally comprises of 118 elements. Okay, students, this is the present table. The present modern periodic table was proposed by the scientist Henry Moseley, and the table totally contains 118 elements. Okay, he said that according to him, the physical and chemical properties of the elements are based on the atomic number, not on the mass number, based on the atomic number. Okay, the properties of elements mainly depend upon atomic number. What is atomic number? It is either the total number of protons or the total number of electrons present in an atom. In a chemical reactions, the outer shell electrons only take part in chemical reaction. So the properties mainly depends upon the atomic number. So he arranged all the 118 elements according to the increasing order of atomic number. Students, now you say which one will get the first position? If we arranged according to atomic number or according to the mass number, hydrogen only occupies the first position because atomic number also 1, mass number also 1. Okay. So what is modern periodic law? We already studied one periodic law proposed by Mendeleev. According to that law, physical and chemical properties of the elements are the periodic functions of their atomic mass number. Here only one word you have to change. There you studied mass number. Here you should write what? Atomic number. The properties of elements mainly depend upon which number? Atomic number. That is called as modern periodic law. Okay, students, proposed by Henry Moseley. Table contains what? 118 elements. How the elements are arranged in the table? Increasing order of atomic number. Now we can see the characteristic. Okay, now we can see the characteristic of table. Now we can study the characteristic of table. Like similar wise, Mendeleev's periodic table, here also horizontal rows. See, this is row. This is row. Okay. This is row. Like this, a table totally contains 7 rows and it can be also called as periods. Horizontal rows are called as periods. Totally how many periods are there, students? 7 periods. Okay. And these columns, this vertical columns are called as groups. Likewise, how many groups are there? 18 groups. Okay. So horizontal rows are called as periods. Important 2-mark question. Okay. Horizontal rows are called as periods. Present periodic table contains 7 periods. Vertical columns are called as groups and it contains 18 groups. These 18 groups can be also called as 18 families because each group, that is first group, second group, third group, all the elements contain a same properties. Based on the properties they are grouped into family 1. Group 2 family, group 3 family, group 4, like group 18 till it has how much elements? Group 18. And how many periods? Rows? 7. Okay. So based on the properties, all the elements are grouped into different families. For example, first one is hydrogen. It's a non-metal, except that remaining all are metals with the same chemical properties. Similar wise, they all also has 4 blocks. The table contains 4 blocks based on the subshell. Okay, we know that main shells are there. What are they? K, L, M, N, and each main shell has subshells. What are they? S, P, D, F. Based on the subshells, the table was classified into 4 blocks. S block, P block, D block. Okay, so it has 4 blocks in the modern periodic tables. Okay, students. And now we can study the different names of the families. I said there are 18 groups or 18 families, and these 18 families, they carries what? Names. Okay, each family it was named. Group 1 family is called as alkali metal. Group 1 family we can call it as alkali metal. Second group is alkaline earth metal, and 3 to 12 is called as transition metal. And next each one has its own name. First, that is 13 boron family, 14 carbon family, 15 nitrogen family, 16 oxygen family, 17 halogen family, 18 noble gas. Now we can see the table so that you can understand very easily. Students, now you can take your books and open the page number 142. There clearly the diagram was given there, periodic table of the elements. Okay, if you see the table only, it is easy for understanding. Okay, so I said that, isn't it? It has how many groups? Totally 18 groups. It has totally how many groups? 18 groups. This is the group 1. This is group 1. This is group 2. Okay. And these two are also called as S block elements. Okay. First two group, that is group 1 and group 2 is called as what element? S block element. And the last you can see, this is from 13 to 18 is called as P block elements. And the center part, that is 3 to here 12. Okay. 3 to 12. 3 to 12 is called as what? This one S block, P block, D block, and at the down 2 blocks are given, that is F block elements. Okay, I said no. The table contains totally how many blocks? 4 blocks, isn't it? It's based on the subshells. Okay, so the first 2 is here. First 2 is here. This is group 1, group 2, and also these 2 are called as what block elements, ma? S block elements. Okay, now we can see the name of the groups. The first group is called as alkali family. Okay, what is the family name? Alkali family. And 2 is called as alkaline earth metals. Alkali metals, alkaline earth metals. Group 1 is called as alkali metals. Group 2 is called as alkaline earth metals. Okay, and this 2 block is called as what block? Means S blocks, because when you write the electronic configuration based on the subshells, all the elements end, that is end with the S. End with what? Yes. Okay. For example, sodium. Sodium atomic number is 11. Sodium atomic number is 11. Sodium atomic number 11. So if you write the electronic configuration, 1s2, 2s2, 2p6, 3s1. Okay. So see, 2 plus 2, 4, 4 plus 6, 10, 10 plus 1, 11. So the last sub, it ends with what? The subshell, yes. So if you write the electronic configuration for all the elements in this group 1 and 2, it will end in yes. So, okay, so it is called as what block? S block elements. Did you understood? When you write the electronic configuration using subshells, all the elements that present in group 1 and group 2 ends in yes. Subshell, yes. So only these 2 groups are called as what? S block elements. Like that, P means it ends in P, D means it ends in D, F block elements it ends in F. That's what the name is given as S block, P block, D block and F block elements. Okay, and the first group is called as alkaline metal and second group is called as alkaline earth metals. These are highly reactive elements. The elements that present in these 2 groups are highly reactive elements, and they performs solution, salt solution. For example, here sodium is there. If it reacts with the non-metal chlorine, they form sodium chloride solution, sodium chloride salts. And also the most of the product that formed as a result of these reactions are alkaline or basics. Okay, they mainly form salt oxides. Okay, sodium oxides, they mainly form oxides, calcium oxide, magnesium oxide, sodium chloride. All the compounds that formed as a chemical reactions are mainly alkali nature or basic. Alkaline means what? That it is basics, okay, or alkaline. Both are same only. Okay, basic in kind. We know two types of the acids are there, base are there. These are all the elements that present in group 1 and group 2 forms basic solutions. Hence only the name is called as alkaline metals or alkaline earth metals, and they have most important elements like lithium, sodium, potassium, calcium. Okay, and these are highly reactive elements. Okay, and it has what? Soft metals. Okay, and also the sodium can be called as sodium, potassium are called as soft metals, and these are highly reactive elements, and on reaction they mainly form alkali solutions or the solution, the products that formed are mostly basic in nature. So they will turn red into blue. Okay, we have red litmus and blue litmus paper to identify whether the solutions are acid or base. So it turns, if you put it turns red into blue. Okay, so this is group 1 and group 2 elements are called as alkali metals or alkaline earth metals, and they are highly representative elements, highly reactive elements, and except hydrogen remaining all are metals, and most of the chemical reactions they form basic solutions. Hence only the name is alkali metals. Okay, so this is about group 1 and group 2. The next one is, the next group is which block? That is, we are going to see P block elements. The next block is P block. Okay, so this is a colorful elements. That is, this contains, it's a main elements are present in here only. That is 13 to 18 are called as what block elements? P block elements. It contains variety of elements, and this group can be also called as essential elements. Okay, it is a main, it is a more essential elements are present in P block elements. That is, say oxygen is here, carbon is here, majority of the elements are here, and also it contains variety. Okay, see here, metals are there, non-metals are there, and metalloids. See, boron. See, can you see this one? This is a what? Metalloids. What is metalloids? They show the properties of both metals and non-metals. They will show the properties of both metals and non-metals. They are called as metalloids, and also the aluminum is here. That is metal. So it contains variety of elements such as metals, non-metals, and metalloids. It can be also called as essential elements. The P block can be also called as essential elements containing group, because most of the important elements are present here. And the name of the first one, 13, is called as boron family, carbon family, nitrogen family, and here first element is what? Oxygen family, or it can be also called as chalcogen family. Students, don't forget what? Oxygen family can be also, this group 16 is called as what family? Oxygen family can be also called as chalcogen family. 16th, group 16. What is the name of the group 16? Is means you can say oxygen family or chalcogen family. What is chalcogen? Means the ore formers. Chalcogen means what? Ore formers. Okay. Calcium combines with oxygen to form calcium oxide, isn't it? Most of the metals that present under the earth crust in the form of oxidose, So this family can be also called as what family? Means chalcogen family. Chalcogen means what? Ore formers. Ore means what? The metals, isn't it? That can be extracted in the profitable amount, that combines with the non-metals, that is oxygen, and they form oxide ores. Next one, fluorine. This can be called as halogen families. What is that halogen families? Halogens, isn't it? Halides. What are the halides? Fluorine, chlorine, bromine, iodine are called as what? Or are called as what? What family they are called as? Halogens families. Okay, and they are mostly for produce salt solution, isn't it? Sodium combines with the chlorine to form sodium chloride, sodium fluoride, sodium bromide, sodium iodide. Mostly they are form salts. Okay, so they are the salt formers. Halogen means what? Salt formers. Okay, students, once again, group 13. This group 13, all the elements that present in group 13 contain same properties. Group 14, all the elements present in contain same properties, like that. Okay, so boron family, carbon family, nitrogen family, oxygen family, halogen family. Oxygen family can be also called as chalcogen. Fluorine family can be also called as halogen. Halogen means salt formers. Chalcogen means ore formers. The last one, see, noble gas. Neon, argon, krypton, xenon, radon, all are noble gas. What is the specialty? See, each group, if you see, means each group, that is from here to the last, each rows that end with their noble gas. See, all the rows that ends with a noble gas. It start with the metal and end with one of the noble gas. Okay. So noble gas means what? They are unreactive gas, rare gases. Noble gases are rare gases. Only they are present in little concentration in the atmosphere, and also they does not undergo any chemical reaction because the outer shell of these elements contains a stable electronic configuration, that is 8 electrons. If outer shell contains 8 electrons, then that element is said to be stable. So like that, if you write the electronic configuration for noble gases, all the outer shell contains 8 electrons, so they have stable electronic configuration, so they does not undergo any chemical reactions. Okay students, so from 13 to 18 this is the, and here the metals are there, metalloids are there, non-metals are there, noble gases are there. So it is a main group containing elements. Main elements or essential elements are present here, and it also contains metal, non-metal, metalloids as well as noble gas. So each row, each group, not each row, it starts with a metal and ends with one of the noble gas. And in between you can see, isn't it, this block, that is 3 to 12. They are called as intermediate elements because they have the properties of both the S block and P block elements. Okay, it shows the properties of both. So they are called as intermediate elements, and mostly this block contains what means metals. And see, the periodic table, nearly 80% of the elements that present in this present periodic table is metals. 80% of the elements that present in this modern periodic table is what? Metals. The remaining 20% only non-metals and non-metals, metalloids and noble gas. Okay. So the periodic table, nearly 80% was comprised by metals and 20% by non-metals. And majority, the right side, see here, the majority here, it was occupies metal, and the corner, this corner place only it was occupied by non-metal. So majority is occupied by metals, 80%, and the corner non-metals are present. Okay. And here the group 1 hydrogen we have given the first position because atomic number also 1, mass number also 1. Okay, but it's not a correct position, but even though it's atomic number and mass number 1, no other way. So here only the hydrogen in both Mendeleev's periodic table and as well as modern periodic table, hydrogen only occupies the first position because its atomic number and mass number is 1. Now the intermediate elements, majority of the elements here present is what? Or metals. Okay, wow. Highly reactive elements. It shows both the properties of S block and P block, and it can be also called as intermediate metals, and this is called as D block elements. And the elements present here are called as what block elements? D block elements, and these are also highly reactive elements. Okay, wow. And the down, see, if you see the down, 2 blocks are there. This is called as F blocks, and the first one it is first. See students, the down here, this is called as what block elements? This is S block, P block, D block, and this is called as what block elements? F block elements. Okay, this is lanthanides family, and here this is called as lactanides family. This is also called as inner transition elements because see from here, these elements are supposed to be here, okay, along with this intermediate elements. But when we keep these elements here, because of due to the large number of metals, it goes along with the non-metals, and the classification will not be clear. So what the mostly did means he cut and pasted. That means he from 57 to 71, here from 89 to 103 elements he cut and he pasted here. So actually this element must be present here. Okay, if we take these elements here, the metals will go along with the non-metals, and the groups, I said no, already he designed like that. Each groups contain same property. So if these elements were taken inside, the groups does not contain same properties. Okay, metals go along with the non-metal, noble gas will come along with the metal. So only he cut this 57 and 72 elements were kept, and it is kept down, and this group 2 groups have some similar properties. They are radioactive elements. These are radioactive elements. These elements expose alpha, beta and gamma rays. So these are highly radioactive elements. So this 2 has the similarity. Okay. First group is lanthanides. Next one actinides. Okay. And actually it should be present in the in between 3 to 12. But if we paste this metals go along with the non-metals and non-metals will come along with the metals. The classification will not be clear, so he pasted it down, and here all the elements that end with the subshell F. So it is also called as F block elements. Okay students, so 1 to alkali metals, alkaline earth metals, 3 to 12 transition metals, and here it is called as essential elements, that is 13 to 18 main group of elements are present here. It contains variety metals, non-metals and metalloids and noble gas. This is called as F block elements. First group is called lanthanides, actinides. Actually it should be present here, but if it comes here, I said no, that problem will arise, so only it is kept down. And here if you write the electronic configuration, it ends with an S subshell, here P subshell, here D subshell, and here it ends with the F subshells. Okay, and different names of the families also I discussed. What are the families you understood? Alkaline earth metals, boron family, carbon family, nitrogen family, oxygen family, halogen family, noble gases, lanthanides, actinides. Okay, so this is about the periodic table. And what is advantages over this periodic table? I said Mendele's periodic table have lot of limitations, and here what is the advantage over Mendele's periodic table? Okay, here he arranged all according to the increasing order of what number? Atomic number. He arranged according to the according to his law, that is according to the increasing order of atomic number, he arranged this table. Okay, and this table is more easy for understanding. Okay, he correlates the position of elements with electronic configuration more clearly. Here each element's atomic number he has mentioned, as well as the table contains atomic number. See, this is the atomic number. For example, you can take here calcium. This is the atomic number 20. It is given now students. This is atomic number 40.078. This is the mass number. This is the symbol. Okay, so atomic number 20, mass number 40.078. Okay, don't get confused. These numbers which is written, see, this is the atomic number 19. See, 19, 20, 21, 22, 23, likewise it was going on. Group wise, if you see, means lithium, sodium, potassium, rubidium, cesium, francium, all they have same chemical properties, like that beryllium, magnesium, calcium, strontium, barium, radium, all they have same chemical properties. If you see group wise only, they have same properties. If you see rows, means it starts with metallic properties and ends with non-metallic properties. Okay, it is very easy for remember, and at least first 20 elements name easily you can understand. So day by day you learn, it will be helpful for you. First 20 hydrogen, helium, lithium, beryllium, boron, nitrogen, oxygen, fluorine, like that you learn. Okay, at least 20 elements name you just study in 9th standard. Then later on, if you are going to 10th, you can study the remaining 20, like that you can completely, you can keep it in your memory. It is easy for remember and reproduce. Okay, and also each group is independent group, and subgroups are discarded. See, if you see Mendele's periodic table, group 1A, group 2, group 1A, 1B, group 2, again it was subdivided into 2A, 2B. So a lot of confusions. So here no subgroups are added. So subgroups have been discarded. Okay, only one position for all the isotopes. Here most of the elements has isotopes, isn't it? Same atomic number with a different mass number. Here see, hydrogen has 3 isotopes, but only one place, hydrogen, because 3 isotopes also have same property. So here it has been given one space. Okay, just hydrogen. Okay, have you understood? For example, carbon. Carbon has 3, carbon 12, carbon 13, carbon 14. But here only one space is given, that is 14th position for carbon, because the properties all are similar. Okay, ma? So like that. And the position of the 8th group in Mendele's periodic table is given for noble gas. Likewise here also he has given the last, their 8th group, here 18th group was allotted for noble gas. So all starts with metals and ends with one of the non-metals. Okay, so the transition elements are the intermediate between the left position and right position, that I said no here. It is the intermediate elements are found to be here. So the table completely separates metals and non-metals. The table separates metals and non-metals. The table separates metals and non-metals. Okay, so it is very easy, and lanthanides, actinides were kept down. Okay, and the demerits of this table is the position for the hydrogen is not clear in Mendele's periodic table and Mendele's periodic table. Then the transition elements are inner transition element till outside the periodic table. It was not taken inside. This is the one of the demerit. One is hydrogen position are clear. Hence these elements are kept outside. These two are the demerits of this modern periodic table. Okay students, the next class we will see the remaining the question answer and all I will explain in the next. Thank you.